So I'm going to continue with the next questions. Okay, please take your seats. Okay, because just now someone asked whether I could cover a bit on the quiz revisions. Okay, and because we will have to finish at 3 p.m. later, so I'll discuss the last three questions. I'll just go through it because initially I thought I will give you some time to do before I practice. I mean, before I go through the answers. But if you want me to discuss a bit on the quiz, which is the probability chapters, then we will have to go a bit faster. I mean, I will. I don't have time for you to try it first. Okay, so I'll straight away discuss the answers then. Is it okay? I've uploaded the quiz revisions on the HLMS. Right, the quiz formulas and the quiz revisions questions I've uploaded. It has all the final answers, right? I don't have the workings. You could check, right? If those that I cannot cover today, right? You just go back and do yourself, right? Check whether the final answer is correct or not. All right, so I'm going to continue with the question 3. Okay, the following tables give the frequency distributions of the meal expenses per month by 100 adults selected from a city. So your sample size, your total frequency is hundreds. Okay, you should have hundreds here. Okay, complete the tables and then find relative frequency, cumulative frequency, cumulative relative frequency, and cumulative percentage. So this is your chapter 2, right? For your midterm, I will also ask you to find certain information, not to fill up the whole table, right? So for example, I want to say, what is the lower limit of the first class? Then you need to know how to find it. Okay, the difference between question 1 and question 3, if you look at the table, here, question 1, between the class limits, right, there is no gap, right? 30 continue with 30, 40 continue with 30. So if there is no gap between the class limits, that means the data here is a continuous data. If there is no gap between the class limits. If there is a gap, like question 3, right, from 400, it jumps to 401. That means this variable is treated as a discrete data. Why do we need to know this? Because later when you find your class boundary, it will be there will be a difference when you find class boundary for continuous and discrete data. Okay, so first we fill up the class midpoint. Where is class midpoint? Lower limit plus upper limits divided by 2. Okay, lower limit plus upper limit divided by 2. So just now, we found the class midpoint for the continuous data already. Now we look at this one. Okay, first we fill up the lower and upper limit first. Okay, lower limit is the smallest value in a class interval. So first class interval, 301 to 400. What is the smallest value? 301. Upper limits is the largest value for a class interval. So for my first class, my largest value could be 400. Okay, so second class, 401 to 500. What is the smallest possible value? Smallest is 401. Okay, largest, 500. So follow this, you fill out the rest. 501 to 600, 601 to 700, then 700, 800. Okay, after we find the midpoint, no, limits already, we find the midpoint. Okay, we take lower limit plus upper limit divided by 2. So 301 plus 400 divided by 2. What do you get? 350.5. Okay, so you do the same for the rest. Okay, until the last one should be 750.5. Okay, take the lower limit plus upper limit divide by 2. Okay, next would be class boundary. All right, class boundary is actually the average, the midpoint between the class limits. So for example, upper boundary for my first class, I will take 400 plus 401 divided by 2. Okay, so okay, this one, the first value here, I should take 400 plus 401 divided by 2. So I have 400.5. Okay, for my next value, I will take 500 plus 501 divided by 2. So I have 500.5. So for discrete data, right, the trick, the shortcut is just take the upper limits, plus 0.5. Just plus 0.5, you will get your upper boundary. So 600.5, 700.5, and then 800.5. How about lower boundary? Lower boundary is taking lower limit minus 0.5. So it's actually also the average between the class limits. So this is 300.5, 400.5, 100.5. Okay, this is for discrete data. Okay, and then, okay, class size. Class size is also known as class width. They are the same. Right, how do we get class size or class width? The formula is upper boundary minus lower boundary. Remember, we are using boundary, not limits. So for a first class, I should take 400.5 minus 300.5. So my first class size is 100. Okay, class size is the same for all the class intervals. Okay, so if my first one is 100, second one, third one, all the classes should have size of 100 as well. Okay, all my classes should have the size of hundreds. Any questions? Okay, next question B. All right, fill out, find all these calculations here. So you could either extend the table or if we I'll just create columns here. Okay, we have the frequency. I just write down the frequencies here. 15, 34. It will be better if you put it horizontally, right? Just extend it. If you don't have the space, then you just create another new table. Okay, find the relative frequency. Relative frequency is taking my total is hundreds. Okay. So relative frequency is taking frequency of the class divided by the total. So 0.2, right? 0.15, 8, 34, and 0.13. So my total relative frequency I should get 1. Okay, next. Cumulative frequency. Right, I'll just use short form here. Right, cumulative frequency is adding up the frequency from the first class up to the specific class intervals. So first class, 20. Second one will be 20 plus 15. You just add up from the very first class. So 35. 35 plus 18. Cumulative. I'm looking for cumulative frequency first. Okay. Cumulative frequency. Yeah. So 35 plus 80, 53. Okay, 53 plus 34, 87. And the last one, hundreds. Okay, just add up the frequency. Okay, next would be cumulative relative frequency. Okay, cumulative relative frequency, you can either accumulate your relative frequency. Okay, meaning you can either accumulate this one or you want to take cumulative frequency divided by the total. Right, either one, right, either one will get you the same answers. So if you use this formulas, 20 divided by hundreds, 35 divided by hundreds, and then do the last one, hundreds divided by hundreds. Okay, so 0 0.2, 0 0.35 until you get 1. If you accumulate the relative frequency, right, we will get the same answer as well. 0 0.35 is 0 0.2 plus 0 0.15. Okay, and then 0 0.53, how do you get 0 0.53? 0 0.2 plus 0 0.15 plus 0 0.18. Get 0 0.153. Okay, the last one, cumulative percentage. Okay, cumulative percentage. So to find this cumulative percentage, formulas is cumulative relative frequency times 100%. Okay, so 0.2 times 100 would get 20%. Then the rest just follow 35, 53, 87, and then lastly you have 100%. Okay. Right, this is the answers for question B. All right, question C. Find the mean and standard deviation for the table above. Okay, when you don't see the words or, because sometimes student may ask, should I use populations or should I use sample? Okay, so when you see the words or, if you see the words or, then you use population formula. Okay, population formula. If you don't see the words or, right, because sometimes I may not always tells you this is a samples of 100 adults, sample of what, sample of what. So in this case, you are only saying this is 100 adults. I do not have the word sample. If you don't see the word sample, you still treat it as a sample data. Right. You will only treat it as populations data when you see the words or. Right. So put a notes there. It's nice. Right. So only when you see the words all in the questions, you calculate using populations formulas. So this one, okay, question C, you will find sample mean and sample standard deviation. Sample mean and sample standard deviation. So how to find it? It will be like your question 1 E, right? Question 1E, finding the mean and the sample standard deviations using the group data formulas. So you use this two formula. So you already got your midpoint, class midpoint. You got a frequency. Okay, so what you will have to find would be MF and M squared F. Okay, you got your midpoint just now already here of 350.5, 450.5. Okay, just now the midpoint is, let me reconstruct the tables again, 350.5. Right, frequencies are already given. Okay, so look for MF, find MF, find M square F. Right, has anyone found total MF? Can you tell me the answers? Five. Oh, so many five. Okay. How about M square F? Have you found it? Right, all right. Okay, take your time. Okay, calculate one by one carefully here. Right, make sure you don't calculate wrong here. Okay, so add up all the values. Very large. Thank you. Right, this is the 32 million. 32 million. Okay, you get this value. Okay, check whether correct or not. So sample mean will be taking 55,550 divided by the total hundreds. So average is 55.550. Yeah. 100, sorry, 50, 555.50. My sample standard deviations. How about this? All right. Remember the square roots. Your final answer on the square roots thing. Okay, the guys check your answers. Anything wrong? Any questions before I move on to the next question 4? Anything don't understand? Don't understand. You have any questions? You have no questions. Okay, I will just move to the next questions. Right, for question 4, you are provided with a stem and leaf for the daily spending of a sample group of 35 adults. Right, there are 35 values here. Find the 3 measures of central tendency first and third quartiles. For question C, we will not do it. Right, don't have to construct the tables. Unless we are using the table to find the mean or the standard deviations. The question doesn't ask, right? Okay, you skip question 3. Okay, to find the measures of central tendency is okay. So you have to understand this stem and leaf. Stem and leaf, your raw data, right? You want to extract the raw data. The smallest value will be 11, followed by 12. Okay, you combine the stem and leaf. One values from the stem, one digits from the leaf. Followed by 22, 23, 24. Okay, and then so until the last 273. Right, these are the 35 values. So when you want to find the